So, yesterday we talked about all the different types of real numbers that we'll see. Today we're going to talk about our operations on those numbers. That's addition, subtraction, multiplication, division. We're also going to, tomorrow we'll get into exponents and some basic roots as well. So, these are basic operations on real numbers. Now, a couple caveats that I want you to kind of pay attention to. A lot of this stuff your calculator will do, okay? I'm fully aware of that. But there's some things that you need to be aware of, ladies. Is there something I can help you with? No. You sure? Just trying to find our So, it's really important, even though your calculator can do a lot of this work for you, you need to know the underlying steps. A couple reasons. One, a lot of this stuff is faster for you to do than to plug it into your calculator. Okay? A time test, 45 minutes to take it, or when you take the SAT, it matters. So if you can do something faster just by working it out rather than trying to plug into a calculator, it's going to be beneficial to you. Secondly, if I had $1, every time a student plugged something into the calculator incorrectly and then just took the answer and said, yep, that's it, and then went with it, the calculator is only as smart as the input that you give it. And it's really mistakes, okay? You type a 4 instead of a 5, okay? Subtraction instead of a negative, all right? You forget to put some parentheses where there's very easy things that you can make mistakes on in the calculator. If you don't have an expectation for what your answer should be, you don't understand what type of answer you should be seeing on the right, okay? And as simple as, okay, I know that I should get a very small negative number, okay? Or I should get a big number with a decimal or something. You predict what your answer should look like is going to alleviate a lot of the frustration of getting things wrong for some, right? And so that's why you need to kind of understand these steps as we do them. So the first thing we're going to start with is our addition and subtraction of our real numbers. And this applies to fractions, decimals, radicals, exponents, all of it. If you're adding two expressions together, they follow these rules. If they have the same sign, you just add them together and you keep whatever that sign is. So if you're adding two positive numbers, you're going to get a bigger. If two negative numbers together, you're going to get a bigger number. If you're adding and they have different signs, then you're going to subtract the two numbers and keep whichever one is larger. And I like to make an analogy with money. Okay, money is kind of the easiest way to think about it. With paying, I borrow $5 from Willa. Okay, tomorrow I come to school and I have $7 and I'm going to pay her back. Do I still owe her any money? Or do I have money left over? Money left over. How much? $2. 7 minus 5 is 2. Okay? And because I had more money in my name than the debt that I owed, I have a positive balance. But if it was the other way around, I borrowed $7 and then I come to school with 5 to pay her back, I still owe 2. 5 minus 7 is 2, but since the negative balance was more, it's a negative 2. Okay? And so we're doing a subtraction and we're keeping the sign of whatever value was larger. Okay? Subtraction, I don't like to think of it as subtraction anymore. Using additive inverse, because why remember two new sets of rules when what we can do instead is make a small change and we have a subtraction problem and we turn it into an addition problem, and now I can just use my addition rules. Okay, so we call that additive inverse. I changed subtraction to addition. I changed the sign of the second number. So if I had, okay, go back to 5 minus 7. So if I have 5 minus 7, I can change it to addition, but then change the sign of my second number, and now I can just use my addition rules. Okay? Or if I had negative 5 minus negative 7, again, I can just change the sign of the second number and then use my addition rules. Okay, I'm going to do something similar. Okay? So, let's go ahead and look at some examples. All right? So before we even look at what the numbers are going to be, If I'm adding -4 and -15, am I going to have a positive result or a negative result? Negative. Why? Why is it going to be negative? Close. Okay. We have a negative value being added to a negative value, so we're going to get a larger negative number. All right? 4 and -9. If I add those together, am I going to have a positive or a negative result? Negative. Why? There's only one negative, and the negative is greater, so a larger number. Okay? I have $4, but I owe 9, so I still owe money. On the subtraction, we're going to change it to addition. So this is going to become 2 plus what? -11. Good. -4 plus +2. Okay? And so for A, I'm going to end up with a negative answer again. And same thing for B. All those just happen to be negative. Don't read into it. Just the way the problem's worked out. So if I do -4 plus -15, I know my answer is going to be negative. And since they're the same sign, I just have to add the 4 and the 15, which gives me negative what? Good. All right. Since I have different signs on B, what am I going to do with 9 and 4? And that gives me what? Yeah. And so I knew my answer was going to be negative, so I get -5. Okay? And same thing on the right-hand side. Subtraction just turned into addition, but follow the same rules. Different signs. Subtract. -11 plus 2 is going to give me -9. And then -4 plus 2 gives me -2. Okay? And again, doesn't matter if they're decimals, doesn't matter if they're fractions, doesn't matter if they're radicals. We're adding two things. Same signs, add and keep. Different signs, subtract. Okay? Questions, comments, concerns on that? All right, now, give me the result of -15 plus 21. -15 plus 21. Okay. Different signs, subtract and keep the larger. Okay? So 21 minus 15 gives me 6. 21 is bigger, so we're going to keep it positive. All right? Next one. -15 minus 3. Well, it has to be repeated.
That's a strong word. I'm being bullied. Hey, you. This should be my senior quote.
If I rewrite this as an addition problem, this becomes -15 plus what? -3. Okay, -15 plus -3. So I'm going to add and keep them. That's how you get your -18. So the reason the parentheses are there is so that there's no confusion in what the expression is. Adding a negative number to what's before it. Okay, so that's why we put the parentheses to make it. If you don't, it just looks really awkward and confusing if you don't put the parentheses. All right? same signs, add and keep. So negative 9.1 and negative 2.3 add to give us negative 11.4. Okay, add and keep. Two negatives add together to give us a bigger negative. Uno más. Rewrite it as addition first. Rewrite it as addition first. Yeah. So you change the first thing to addition and then change the sign of what's in the parentheses. Good. So change it to addition, make this positive, then we just have 9.1 plus 1.2 to get our 10.3. Okay? Now, this one has three values in it, two operations. So I want you to look at this first and tell me, how would we rewrite it so that it's only addition? Rewrite it using our additive inverse so that it's only addition. No, we're not getting an answer yet. We're just rewriting it so that the only operation I have up here is addition. Okay? This is the only one we want. Okay? I don't need to change the 2 plus 7. It's already addition. But I do need to change the minus 5. So we're going to rewrite it as plus negative 5. And then we can just go from left to right. What's 2 plus 7? 9 plus negative 5. 4. Okay? And no matter how long or complex it gets, rewrite the whole thing as addition, and then you can just work your way left to right, solving each one as it comes. Okay? Because that's what you're going to do on this one. So you're going to want to actually give me the answer for this. Okay? What is negative 4 minus 2 plus 8? Okay? 2. So negative 4 plus what? 2. Negative 2. And I don't need to change the plus 8. So when I look here, negative 6 plus negative 4 plus negative 2 gives me negative 6 plus 8 gives you 2. Rewrite each step as addition and just work your way left to right, all the way down the line. All right? Questions, comments, concerns? Okay. So now, multiplication, division. The rules sound a little similar to addition and subtraction, so it's important you kind of separate, identify the different steps between them. We're still looking at the signs of each of the numbers in the operation, but what the result is going to vary. Okay? With multiplication division, whenever we multiply two values with the same sign, we always get a positive result. Okay? So the product of two positives and the product of two negatives is always a positive answer. Same thing with division. divide two positives, divide two negatives, we always get a positive. All right? If the signs are different, doesn't matter which one's bigger or smaller, it will always be a negative quotient or a negative product. Okay? So same signs positive, different signs negative. The other thing is to note that this has to do with two numbers. Okay, this one doesn't say two. Okay? Two numbers. Two numbers. Alright? If you add in a third number, you have to figure out what the sign will be from your first product and then look at that and then the third number to see what the result is going to be. So if I have 2 times negative 5, is that going to be positive or negative? Negative. But what if I also had times negative 7? So I have negative from the product here times a negative number, positive for the final one, and then a negative 8 at the end. My final result is going to be what? Negative. So every time I add a new number, I have to repeat that process to see what the sign is going to be. Okay? And so you can look and say, okay, well, this is going to be negative, and then this negative number with this negative number is positive, but then this positive number with this negative is going to be negative. Keep going back and forth as much as you need until you get your end result.
What if you added another number after that?
Depends on what number I add. So if I add another negative, it would make it positive again. If I added a positive number, then it would keep it negative. Okay? Because I had a positive and then it became another positive, so now the signs are the same. So it just kind of depends from situation to situation. All right? So I want you to look at these 4 values, and I want you to tell me which the following products will be positive. Which of the following products will be positive? Got a couple tricky ones in here. Which of these products will be positive? Okay. All right. Same sign. -9, -2 gives us a positive product. Good. A lot of us got that. Different signs is negative. Okay. Doesn't matter how big or small they are. Different signs are going to be negative. 0 times -12 is going to give me what? 0. Anything? 0 is neither positive nor negative. It's nothing. Okay? 0 is nothing. It is not positive. It is not negative. All right? So if you multiply by 0, you won't get either a positive or negative value. The last one's going to be positive because 2 positive numbers is positive, 2 negative numbers is positive, and then we just have positive numbers all around. Okay? I'm positive that the last one will be positive. Now look at these quotients and tell me which ones will be negative using the same rule. Okay? Same rule. Alright, different signs, negative, good, same sign's going to be positive, so we're not going to choose the 16 over 4. Different signs, negative, good, and then 12 over 0. What's 12 over 0?
0.
No.
Oh,
Undefined.
oh, right, because 0 is like, it's the opposite.
If the 0 was in the numerator, yes. You can divide 0 by anything and you always get 0. But if I have a denominator of 0, if I'm dividing by 0, it is undefined, which of course, undefined is not going to be positive or negative because it's not anything. Alright, this is as far as we got with the other classes, so this is where I'm going to stop for today.